Olber's paradox. If you're in the middle of a large, dense forest, wherever you look, your line of sight will end at some point on a tree. Olber's used this idea as evidence against an infinite universe. Olber's paradox brings up a problem if the universe is infinite, the speed of light is infinite, and stars have an infinite life. Of course, now we know none of these to be true. If this was the case, Olber argues that wherever we look in space, eventually a star will be at the end of our line of sight. Therefore the night sky should be just as bright as the day sky, which of course it isn't. Olber considered spherical shells around the Earth. The surface area of a sphere is given by 4 pi r squared, so the volume of a shell of thickness t will be given by 4 pi r squared t. Therefore the volume of the shell increases as the square of the radius, and so will the number of stars that the shell contains. But light intensity follows an inverse square law, so the intensity from any one star will reduce as the square of the radius. This means we should gain the same light intensity from each shell, giving uniform light intensity to the whole sky. To illustrate that, here we have the Earth within an infinite universe with stars evenly distributed. If we have a shell a distance r from the Earth, and a second shell a distance 2r from the Earth, the outer shell has 4 times the volume and so contains 4 times as many stars as the inner shell. But each star will produce only 1/4 of the intensity of those in the inner ring at the Earth, due to the inverse square law of the light approaching the Earth. Therefore the intensity of the sky in all directions will be uniform. This was seen as evidence for a finite universe.